So I guess it's about a year and a half now since my epiphany. And it really was this kind of thing. It's I was primarily, I would have called myself a vision scientist for most of my career. And it was a computational vision and it was Bayesian, broadly speaking. I've spent most of my graduate career learning, hearing about how connectionism, as it was called at the time, wasn't going to work. And then what happened was, say about circa 2013, 14, really started paying attention to what was going on the neural network sides, CNNs, and the fact that these things were doing what looked like something at least approximating a really important piece of what we call cognition.
Mm.
And it was limited, obviously. It was labeling. Application wise, it was certainly not entirely clear where things were going, but these things kind of like proto brains in a way that really just kind of re-steered my interest, refocused me. And so I kind of at that point started to transition away from some of the Bayesian approaches to actual modeling because now the models could do stuff. And then what happened was when the large language models hit, I was flabbergasted, truly flabbergasted. I actually was a little more surprised. I had a pre-LLM moment when the image generation models,
Mm.
people didn't quite notice, but they were getting so good that it was obvious that they were understanding language, even though they couldn't speak yet, right?
Hmm.
So the
Hmm.
generation was all on the image side. But not only did they, do a really great job of creating images from text, but they seemed to have an understanding of sort of subtext. Like they had a sense of humor almost. I was like, what's
Yeah.
going on here?
Yeah.
These things not only seem to understand how to generate images, they seem to understand not only even language, but they seem to understand sort of the cultural
Yeah.
sort of implications of language. And that was when I was like, okay, these things really this is intelligence. There's real intelligence here, like almost in a freaked out way. Like there's an intelligence here. It's a non-human intelligence, but it's there. And then when large language models dropped, and I specifically understood sort of the autoaggressive nature of things. They were just doing this next token generation. That's where I had my sort of key epiphany, so to speak. That what I realized in almost an literally moment is, oh, language itself is intelligent. Language itself has the capacity to generate itself, because that's all it's doing, right? It's just astounding how simple in some ways, and how and you could say almost like devoid of any what we would think of as sort of the complexity of cognition and what I think we have always assumed to be this underlying sort of cognitive modeling and all this stuff. That's not what's happening. What's happening is there's a statistical distribution of tokens, whatever the heck those are exactly, but in the models, these are just vectors that happen to represent text. Well, I shouldn't say happen to represent text. They represent text, as these vectors, and then all these models are doing is just representing the distributional structure of the corpus and using that to predict the next token, and then doing this autoaggressive thing. Then just saying, okay, here's a sequence. How does the sequence? I don't even want to say how does it probably continue. It's not the right terminology. It's not really prediction, but it's how should it continue? And it's using just the internal topology of the data itself. And then the epiphany was like, oh wait, that means language kind of just continues itself. And that means it doesn't need anything else. It doesn't need a world model. It doesn't need anything like, it's not an inferential process where it's trying to guess what's true about something, some other external system. And so Bayes, all of that, but basically sort of the core foundation of the way I've been trained to sort of think about what cognition is doing. And it's sort of modeling of an external process. It's not modeling an external anything. It's simply using its own statistical structure to continue itself. And so this was this crazy moment of like, wait, language is its own informational organism almost, so to speak. The data itself is doing its own work. what the hell does that mean? For a couple of things. Number one is, what does that mean for language? And so the first thing that for months that I was just walking around in a daze about, almost literally, ask my family, is like, wait, so what do words mean? Oh gosh, they don't mean anything. They don't mean, or not in the way we've historically thought about it. The word red, and we think it picks out a color, right? There's this idea of reference. It goes on, going back to certainly the philosophy of language, but it's not about the philosophy of language. It's about uh, historically how humans have sort of thought about language, probably forever, or at least as long as anybody's thought about thinking that words kind of refer, in a sense that like there's some sort of really deep connection between the world out there as it comes to our senses and the way that language is an extension of that, and it's sort of directly picking out or we're referring, however you want to phrase it. But language doesn't need that, and it not only doesn't need it, it can't have that if it's running based on this kind of next token, internal distribution, then there's no room for other kinds of computational mechanisms really to be doing the generation. Now, I'm not suggesting that there isn't interaction. When I'm looking at you and I'm saying, "Hey, there's Michael Levin," I'm not saying that language is just running on its own. How did it find out that Michael Levin's there? It finds out. There's stuff and we can think of it, it's like prompting. It's just like the multimodal language models. You can take images in, and that information can go and be projected into the linguistic space. But the language then still is running all on its own logic. And by the way, I should have said earlier on, like I made the jump. Not everybody does, but I think really solid computational reasons to believe so that this is true for language models, and it's true for our language too, right? That was sort of the epiphany. Not, oh my gosh, these models are really cool. They can do stuff, but that's totally different from the way humans do language. I think that obvious conclusion is that if this is true about language and it has this property and it's able to do this, then that's how it's operating in us as well. It's a very controversial statement, and if I just go ahead and say it, I don't, you and nobody else really has reasons you have to believe me on it. I have a more elaborated version of why I think this is true. I have actually some recent computational results that I think really strongly, indirectly, but very strongly point to this. But basically, that was the big epiphany. The epiphany was language seems to be this ungrounded, or at least this parallel system that has its own informational structure. That's what it's doing. Somehow, those properties are very useful for things like communication coordination. There is obviously interaction with the rest of the system, but so language is this ungrounded thing. That was sort of the primary initial epiphany. And then from there, I got to thinking, because, kind of obsessively thinking about this, like what on earth what's going on here? And I haven't sorted out what's going on. I still don't understand. It's much more mysterious now, how language actually works. It's what's weird about it is, like, in some ways it solves a riddle. How does language have reference? And the answer is it doesn't have reference in the way that people have traditionally thought about it. At the same time, it works, right? It does all this coordinative behavior, but it's doing it in this much more probably indirect way than we've thought about it. But that got me to thinking about, okay, well, if language has this sort of information, this computational structure of you take sequence, and based on distributional structure, you generate the next thing, and tack it on, and then run it again, right? Beautifully elegant kind of computational property. What else might this not what else might apply to, but uh, how did we get this? Where did language come from? It was sort of the big question. How could we have this crazy computational structure that does this thing and it does it usefully? And that leads me to the more conjectural than I think language, but I think a pretty solid conclusion in my own mind, that there was autoregressive cognitive infrastructure already there. That the brain works this way. So what I mean by that is that we're probably learning the distributional structure in general of how sensory perceptual information comes into our system, and then what the impact of behavioral decisions is on that stream. And we're probably doing something like autoregression more generally in cognition. And so it's instead of thinking of sort of predictive processing, where what you're trying to do is predict the next input, what you're really doing is probably just generating the next useful output. So it's a longer kind of and I want to give you a chance to respond, but this is sort of the sequential thought process is that that cognition itself may more broadly be understandable as this kind of autoregressive or at least autogenerative. So I think it's my own term. I use this term autogenerative. Autogenerative just means you're using it's a system, or you can even think of it as a property of data. When data has the capacity within the data, the distributional structure of the data is sufficient to generate more data, generate more of itself, but just keep things sort of quote unquote within distribution. So it's autogenerative. So language is the paradigmatic example of this. Language has now we know has this property that the corpus itself is finite, right? It's inherently finite, but you can get infinite out of it, right? This is sort of the productivity. We've known, language has this productivity kind of capacity to, and we see it every day. Every conversation is a novel conversation, and with the LLMs, you can ask it about anything, and it will produce a reasonably, I think, very reasonable, coherent response. And so the idea is that, right, the data set. I don't know exactly how to characterize it yet. And this is my current way of characterizing it. The data set is this finite thing, but it has within it the capacity just internally. There's no external rules, nothing external to it that allows it to generate, or that one could use in order to generate. All right, you're given a model that's able to do it. Now, so it doesn't necessarily have to be this autoregressive sort of mechanism. I think that's the right one. I think humans do operate autoregressively. We kind of do. When we talk, for example, we're producing the next word based on what came before, but it's a more general property that within the data it has this structure. You could do it differently. You could do it diffusion wise, for example. It doesn't have to necessarily be that you just guess next token. You could guess a bunch of tokens all at once, but it would still be based on the internal structure. That's one thing that's incontrovertible from the large language models. Like language has this structure to it, this autogenerative structure. So the further, the further thought is that maybe, perception and in general, the world has this predictability to it. We might even call it physics, but it's a very different kind of physics than we think. But it's not formulating it in terms of here's a set of rules, here's a symbolic description. It's that the data, as you collect enough data about the way things move and the way things interact, that is actually sufficient to say under this circumstance, this is how they're going to move, this is going to interact, and that our brains are kind of have captured that sort of or our brains in some way are meant. They're designed. What they are these continuation machines. What they learn is how do things continue? How do processes? What is the predictive structure such that you can take a given sequence, like the last few words I've said, the way I'm moving my hand, the way this is going to fall if I let go of it, things like that. All of this, our brains are built to actually. And I don't like the word predict, but to extract this or somehow represent this I guess you can call it predictive structure, right? I struggle with the word predict. The reason I don't like the word predict, just to get it out in the open, is because prediction kind of assumes that there's some external thing that you're trying to model, and then you are saying what's it going to do, and then you're matching that, and you're saying, okay, did I do a good job of predicting what was going to happen. I don't think the brain is necessarily doing anything like that. So I do kind of disagree with what we typically call like predictive processing. I don't think your brain is saying, I think fundamentally this is what's going to happen next. It's modeling the sort of internal structure of the way things happen to do stuff, right? As opposed to predict stuff. Prediction is something that people who play, the stock market, or trying to predict the weather, want to know about some external process. What we're trying to do is navigate the world. We're trying to make in real time make the right choices as to what to do, and how to continue our own internal process such that that it's optimized somehow for survival or for whatever, reproduction, whatever the heck your evolutionary model is. But in any case, so that's sort of the key idea that I've been working on here is that the brain is fundamentally doing this kind of generative process, just like the large language models. And people often will say, well, you're just glomming on to the latest sort of technology. Once it was steam, and then it was digital computing, and now it's large language models. But this is really a computational argument. It's not about a technology. It's about the fact that technology revealed something about the underlying structure of language, in this case, right? So these models, the transformer models, they don't make anything. They're not smart in of themselves. They are just I think of them as like Jello. You put them in the mold, and they will take the form of whatever structure is there. What they did was find this structure that was already in language. It's the revelation was that language has these properties, not that the models can learn it. And then from there, you just have to say, well, okay, the brain seems probably, given that we're the ones who created language, the brain seems to have the capacity to learn this kind of structure. Oh, then presumably it's learning that kind of structure more generally. Very unlikely that language ex nihilo just emerged. The brain is suddenly able to do this kind of structural learning. It's distributional structural learning and continuation. Maybe that's the whole thing. That's sort of what cognition is. And then the final piece of this that I think a lot of people see when they hear this theory and say go talk to Mike about this, is sort of the autonomy and I don't know how else to call it, sort of ontology, um, of information, of computation. That what the heck is language? It's not the words, it's not the sounds, um, it's some sort of informational structure. And the fact that you can do it in a completely different substrate with a completely different representation. I'm not suggesting that the brain is literally doing tokenization in the same way that the models do, but yet they're able to capture the all of the basic performance. Really suggests that language has a sort of substrate, and even any sort of manifestation. It's independent of any of that. It's not about sounds or words as we think of them. It's about this relational structure. It's math, in the most abstract way, in some sense. It's about just relational structure between tokens, right? Relational structure between vectors. That gives you language. So it suggests that language, it doesn't live in the particular manifestation that we think of it as living in. It's not really about these, we turn it into sounds. That's how we do it. It's how do we get it out of our brain and into somebody else's brain. That's just our way of doing it. But now we know you can do it completely differently. And so that kind of speaks to almost a little bit of some sort of computational essentialism or something like that. That the mathematical structure is what's doing the work. And it's manifesting, it's running in our brains in this particular way. But there's, I don't want to use the P word, platonic, but it certainly it has hints of that. That there's this kind of sense in which the information precedes, that the mathematical structure precedes any particular instantiation of it, and that it can be instantiated in this way or that way, right? This shadow or that shadow. These are in some ways like different projections of it. I don't like necessarily to use the word projection because that sort of assumes like a certain dimensionality or something like that. But it certainly is these are certainly very different manifestations, I guess you could say, of some of the same mathematical structure, and it's not just theoretical; it's happening in us, right? It's this is what the language is running in us, in and it's very hard to say exactly. We don't have the right terminology, but that is a sort of kind of, it from bit, if you want to think about it that way. The mathematical structure is what's is imposing itself on our brains, and making them do the things they do rather than the other way around. So I think that's maybe sort of in some ways the most sort of broad and we could call it philosophical or whatever we don't call it, kind of in perspective here on all of this. But it definitely, I think, has some resonance with the kind of ideas that I know you've been discussing in relation to sort of Platonism and things like that. So yeah, that was a big download. You were nodding enough that I hope it made some sense. But that's basically what I've been going crazy about for like a year and a half now.
Yeah, super interesting, and there's a few sort of points of intersection with us, and in particular, why I'm interested is because this is what you have is another amazing example of some things we're very interested in. So the first kind of concept that we deal with is this notion of a virtual governor. So this is back to Norbert Wiener and so on. This idea that in certain systems there is you can compute the existence of a virtual object. Object I use very loosely, but because and people complain that I'm sort of trapped in this that it should be more processual and not so much substance and all that. I get all that. The only reason I say it's an object is because it's a target of intervention. Okay, it's an actual thing you can intervene on and relate to. And so the idea is that this virtual governor doesn't exist in the physical world. It isn't physically there, but once you've defined its properties, if you aim your intervention strategies to control, communicate, whatever, interact with this thing, you gain way more control of the physical stuff that is there. And I think the original example, though he didn't write actually that much about it, but the original example was there was a set of dynamos and they're sort of coupled, and because they're coupled, they're very hard to, the whole thing is unstable. It's very hard to control, right? If you try to control each one, the whole thing
Mhm.
sort of flies out of control. But you
Classic
can
complex system stuff.
what's that?
It's like classic complex systems.
Yeah. And
Yeah.
and so what he showed is that you can define a virtual governor that isn't there. It's like a virtual dynamo, and the idea is that when you manage that one, actually you get much more control of the system. So it breaks us out of this idea that the targets of your intervention are physical objects. They can be these complex, and I don't want to just say state because that's too passive. It's not actually a state. Neither is it an object in the
In the physical.
in the passive sense. It's an object the way we are objects, which is not really objects at all. And so for us, the idea is that we study these things in physiology. So the idea is that, okay, we have when we're looking at embryos or bodies or whatever, we've got that there's the biochemistry and there are the pathways and everything. We're fine, and there's lots of people obviously working on controlling those things, but there are persistent states that might be bioelectric, they might be metabolic, they might be stress kinds of things. They exist in different spaces, and these things have their own, at minimum, they have their own persistence. That's minimal because you can track them across the matter kind of sort of comes and goes, but the state stays. You can minimally persistence, but more than that, they have policies of behavior. so you can actually make models of what the heck are these things doing. And then depending on which things you're looking at, they might be higher on the Rosenbluth sort of hierarchy, where they may have homeostatic states that they're trying to achieve specific simple ends. Sometimes they might be predictive, sometimes they might have self-preservation properties. And this is anywhere from bioelectrical kinds of patterns all the way through how they say the persistent thoughts and repetitive thoughts that are hard to get rid of. Sometimes they even do a little niche construction in the tissue to make sure that they can kind of hang around, right? So these kinds of things. So that's the first thing, is this notion of I'm right there with you, that that a lot of things that aren't physical things have important reality and function. They can be functional drivers of what happens, right? So that's kind of the first thing, and we do a lot of that in physiology. The second thing is this notion of active data. So we have now a little bit of work, especially with Chris Fields and some new stuff coming on, trying to dissolve this boundary between thoughts and thinkers, or between data and machine. And the standard paradigm is, you look at an agent like a Turing machine, you say, okay, that thing is the active agent, and then there's some passive data that it operates on. So you can flip that and say, no, the machine is just the sort of stigmergic scratch pad in the world. It's the data that drives everything. It's the patterns in the data that are the boss, right? And so you can start to think about how to dissolve that distinction, and you can actually make a whole spectrum of it. It's not a binary. I don't think it's a binary thing. I think it's actually a spectrum. So that's very interesting, and that gets us to the notion, what you said about the machine being jello and so on. Yeah, that this is kind of, I hadn't said this much previously, but this year I've been leaning on, for various reasons, I've been leaning on this idea that in certain ways, the physical embodiment, whether that be the evolved body, some sort of hybrid thing, and a robot, LLM, whatever it is, the physical thing is kind of an interface. It's right. It's not the main show. It's the and for this reason, I think a lot of the theories we have about computation and the thermodynamic costs of computation and what's possible and not possible, all of these things are good theories of the front end. They're good theories, right? But in an important sense, I think all of these kinds of things are kind of thin clients through which the active, I don't even want to call it data, because even that's too passive, as I think you said as well. It isn't just data. There are these patterns that they might be higher on the hierarchy, and you can't just assume where they are, right? And so as I was listening to what you were saying, I had this kind of analogy in mind. What if we think about language or text? I'm not sure, but let's say language as a kind of any instance of it as an instance of a developing organism. And what I mean by that is here are some things, and probably the analogy blows up in many places, but here are some things that I think are cool. First of all, it has an interesting kind of trade-off between independence and interaction with the real world. It's independent in the sense that it is going to develop across it, like it has a developmental sequence, right? And in language, what's the next word or whatever. Well, in development, you say, what's the next developmental stage, right? And so part of it is exactly what you said, meaning as an embryo, I exist in and of myself. I don't need you to tell me what's going on or for you to run my program or any of that. I'm developing on my own, right? So there is a first person kind of perspective there, whether it's a high level or not, but it's there, and it's going to develop in a certain way, and yet the specificity of how it develops does have a historicity to it. The reason that you develop into a snake or a tree or a human or an anthrobot or something else, because your genome is actually compatible with a huge number of outcomes, right? So there is plasticity, but there is some influence, right? So there is some interaction with the outside world. And so whether that's for mammals and things, whether that's the mom, or for a lot of organisms, that's really the outside world or the history, right? The evolutionary history of what happened. So there are some inputs into this process, but there also is this like first person driver. I'm going to develop in a certain way, and whatever else happens, the metabolics, the thermodynamics, all this other stuff, it is so the physical machine that embodies it is in many ways a side product of what's happening, right? And I think an important part of that is to whatever extent anybody who goes along with this idea, they usually think of it as, okay, so there's this anatomical amorphous space. There are different shapes that you could acquire. Some of them have been built by selection. Some of them, who knows, like anthropods, whatever, who knows where the hell that comes from. But let's say there are some attractors and things, and you are the physical agent that is sort of navigating this space. and I think that is useful in some cases, but I really want to flip it and say, no, you're the interface through which patterns in that space come through. In other words, the space isn't passive, and these attractors aren't passive, and they don't just sort of sit there waiting to be found. And actually, Chris Fields and I are writing something else now around this idea of to what extent can you say for any problem solving system, so an intelligent system choosing what to do or choosing looking for answers in some problem space, to what extent are the answers reaching out for you as well, right? To what extent is it a symmetrical kind of thing? So we have some examples of these things that we study, and I love this idea that language is one of them, and that it can do, like, I wonder in terms of practical uh things, collaborative opportunities, whatever, going forward. I wonder if we can we did a little bit of it with Francisco Sacco. I'll send you a paper of sentences navigating that kind of space, but I think we can do a lot more in thinking of these things as a kind of a developmental process with its own sort of inner perspective. And to what extent are the machines that embody these things, whether they be the brain or whether they be LLMs or whatever else is possible, these things are interfaces through which an important pattern tries to manifest itself. So yeah, I
Yeah,
think
yeah.
lots of areas of intersection
Yeah,
here.
exactly. And yeah, I think that this was when we were talking with Andres, that there was that conversation we had. It was a virtual conversation. I don't know if you remember. I was at University of Toronto. It was the three of us, and I remember you had said something right along these lines, that there's the idea of these computational structures or something as sort of being primary, and then they're manifesting in these ways, and I was like, hell yeah, because that is sort of the craziest insight from all of this, and at the same time it's very, very, very difficult, and almost it's almost Ouroboros. It's like because we're using language, and we're talking about representational schemes, and we're using our representational schemes to do that. And I don't want to get caught in like philosophical morass. In some ways, this is I think a lifeline to pull ourselves out
Mm.
of the solipsistic, thinking about thinking, and all of that. But I do think that there's a dramatic, truly, truly, like, paradigm shifting kind of way of thinking about things differently, that our brains are not built to do, really, because whatever the illusion of reference, or illusion of objecthood, it's being primary, and it as opposed to bit, and sort of that's how we've evolved to think this way, and we're kind of trying to be like, we're trying to step outside, in some ways, and reframe. So it's obviously it's inherently very difficult, to come up with ways to capture this in a way that ends up uh, understandable within our framework, because we're talking about our own framework here, right? And understanding our own framework, but we can't, obviously, like, in a Gordelian way, we can't, like, really get out of our own framework. So it's very challenging to think about these things empirically. And I think that's, if there's work to be done here, it's to inch our way towards a sort of this bigger, kind of a truly, it's a perspective shift, as opposed to individual, individual phenomena. So the individual phenomena, I think, would be towards trying to capture this idea,
Yeah.
this core idea. And so what I've been doing personally is been trying to say, okay, what can I do to sort of prove in some limited form, that language has this structure independently, and in people, that is how language has to be operating, but it's towards this broader point, and so, yeah, coming up with precise experiments, so to speak, um, is inherently very challenging, in this context, but this is, it's worth it, I guess. So, in some ways,
Yeah.
it's like, biology is really cool, language is really cool, But you know what's even cooler? Metaphysics, right? Or whatever the heck this is.
Yeah,
I don't know. That word is rightfully could turn people off.
yeah,
I think both you and I are not trying to say, hey, we're anti sort of physical, like it's not exactly an anti-physicalist story. Exactly. I don't know where you fall on that.
yeah,
Um, it's not the old version of it's not wooey. It's not like it's not some other substance. It's like spirit, which I think, was really just like crappy materialism. It's like because
yeah.
there's this other thing that operates just like the physical, but it's not physical. This is it's different. It's more abstract than that.
Yeah. I mean, I think well, it's funny. It's not wooey in the sense that we should be doing experiments and technologies, and I have some ideas for like making maybe practical implications, but it is wooey in the sense that math is wooey. So
Yes, yes.
right when we have this successful research program over thousands of years where supposedly we start with set theory. So well, I have this empty set, and then I can put one thing in it, and like that's it. There's your right. There's your start, and then
It,
before you know it, you get handed a very specific value of E. Like it's 2.7.
yeah,
Like
yeah.
what the fuck? Wait, what?
Totally.
And then there's there's all these weird all these different truths of number theory and of topology and of these things that you just find them. You're committed to them as soon as you do something as simple as as start in on with very minimal assumptions. You get all this stuff that is just kind of handed to you, and all this stuff is it matters in the physical world. It matters for physics, right? If you ask, why do the fermions do this or that, you find out, oh, it's because there's this symmetry group that's like that, right? Eventually everything ends up in the math department, whether you start in biology or whether you start in physics. Like eventually it's all about and
All
so
woo.
what's that?
It's all woo.
Well, yeah, because right, because what I think, and I mean, I realize there's people that disagree with this, but I've been talking to a lot of mathematicians recently about this, and I think there's not really any way to escape the fact that some physical facts do not fix all the facts. So if you know everything there is to know about the Big Bang and the you can twiddle the constants at the beginning of the universe, whatever, you are not going to change E, and you are not going to change Feigenbaum's constant and all these other things,
It's not in there.
right? It's not
Not
in
in
there.
it.
It's somewhere else. And
It's
so
it's
and so
it's it's above it.
that's
It's
that's right. And we don't have to think about it as naive objects. That's fine. But nevertheless, these are things that matter. These are things as an engineer, like when we talk about, like, I don't know what's woo and what's not, except that as an engineer, whatever I need to worry about or whatever I can exploit, those are real. That's how I see this. And if they're found in physics, great. If they're found in the math department, also great. That's my simple metaphysics here, is that if I need to worry about these things and if I can exploit them and relate to them in a functional manner that helps me discover and build new things, then it's real. And if that's not woo, then great. Then many other things aren't woo either, or maybe it is, and I don't care. It's fine. But there's something here, right? This like the thing that Descartes got beaten over the head with, which is this like, but how can a non-physical thing interact with the physical body? Like you need conservation of energy. We already had this. Never mind the biology and the brain. But, back Pythagoras already saw this, that hey, there are these like totally non-physical facts that somehow make it through and constrain physics, and then I say they enable biology, and all of that. We already had this. We already had this interactionist problem. Like if you're into math already, you're an interactionist. I don't think there's anywhere to go from there,
yeah.
other than that, right? So I think that's fine. The only thing that I think so what's important then is to figure out what we can do with this, right? And what useful, interesting things we can do that would help us flesh it out. And the direction that I'm going, and I wonder if we could do this with language as well. There might be ways to do this. What the research that we're doing now in this direction is looking for what I call free lunches, or heavily discounted lunches. Let's put it that way. Things where you get out more than you put in. I think
Mhm.
that's already. I mean, math is already telling us that that's the case. You constantly get out more than you put in, and so I think where the evidence for this kind of thing that you and I are both talking about is the strongest is when you can definitively measure, like, this is what I did, and I didn't need to micromanage this and that, and yet here we are, because the standard theory says, look, you're supposed to pay for computations, right, and every bit costs, or erasing a bit, I guess, costs a certain amount of energy,
Whatever. Yeah.
right? And so there's effort that you need to put in, and if you're going to have like some kind of controller that's going to do something useful, you either have to learn, so you have to train on data so that you become good at whatever the task is, or so you're either learned or you're selected for it out of a big set. Somehow you evolved, or something like that. But you have to have had history with the problem, and to the extent that our conjecture that language and some of these other things are generative and they have their own thing going on and that you didn't have to put in, the prediction is that you will find that those that they can solve problems and they can navigate these spaces in ways that do not match either of those two standard criteria. They were never selected for it. They were never engineered for it. They didn't train on it. And we have some stuff that's coming out in the next few months showing exactly that. That you can use this kind of thing to solve problems, even though you've had no. It's like zero. I've called it zero shot transfer learning. It's like it's transfer learning from where you've never had contact with the problem, right? At least in the conventional sense. So I wonder, right? I wonder this, just to generalize this issue of getting more out than you put in. I wonder if we can do something like that with language. I don't know exactly what the measurables are going to be, but that's where I'm looking for like
I mean,
quantifiable evidence of this stuff.
would you see the actual, the language models as they exist? And it's not our experiment, but are they an example of that inherently, in the sense that they are just they end up doing all this computational work by virtue of the sort of the structure of language sort of came to the models for free.
Yeah.
They
Yeah.
didn't, right? And this, well, so let me, I don't know if you're a little bit precise about this, because this is like exactly where I'm at right now in terms of like actual experiments I'm doing. Um, there's two ways that things could have gone, or I guess there's two possible interpretations of what happened with these language models. You have this big corpus, and what the models could have been doing, theoretically, is, well, I need to come up with with some sort of structure. I need to come up with this mathematical topological structure that's going to allow me to do this task of next token, and I'm going to use the data to do that, but I have to come up with this scheme. Um, and that's one way to think about what they've perhaps done. The alternative is that more Jello-like, that they are simply reflecting the computation structure that's there, and the computation structure is the thing that ends up doing the work. That the language, it already has it. And I think so. I've done some simple experiments, kind of showing that transformer models, um, they don't come up with their own schemes. They can't come up with their own schemes. So if data doesn't have this distributional structure already, so some of the stuff I've done is, like, if you have really simple rules, like Fibonacci, you come up with like simple rules for generating sequences. The models collapse. They suck at doing it, and that's because the mold isn't there, right? There's nothing to mold to. There's not this kind of distributional structure. There's some external rule, and they can't learn it. So in this case, so I think that's pretty strong evidence that what's happening with the language models is that they are simply taking advantage of the fact that there is already this distribution structure that's ready to do the work. And so, from a clarification standpoint of what you're thinking, is that an example of that? That you've got sort of the computational model itself that's like, I got to do this task. And it's like, oh man, there's this thing called language. I got to do it. How am I going to do it? And if it had to really figure out how to do it, then it would have taken, probably more computational resources than maybe I don't want to, use these kind of loose terms, but like then it would have taken like this many, an infinite, not infinite, like the age of the universe kind of stuff.
Yep.
It's like,
Yep.
no freaking way
Yep.
you would ever come up with a
Yep.
scheme to be able to do this, if the data
Yep.
didn't already contain within itself this capacity. So is that a free lunch where
So yeah, so in general, I do think that the ability to interact with or to be colonized by or to be cooperated by patterns from this by active patterns from this space does provide extra compute that you didn't pay for. So and I think I think measurably so, and we have some examples I think of that. But the thing is, much like living tissues and brains and so on, language models are very complex and just structured. Like there's a lot going on. There are lots
A
of
lot
data.
going on, but they're actually not complex, really.
Yeah, you do. I understood, but there are enough details where it's hard to have a clean argument because people will say, well, it's implicit in the structure of the data that was put in, and it's this and that. Like it's really hard to so I make the argument about some of our biologicals too, like when did you like we know when you paid the computational cost to design a human or a frog, it was in the millions of years of bashing against the environment and selection and all that. How about anthrobots and xenobots? When did you pay that cost? Never. There's never been any, right? So right, but they're like biology, just like these things are complex enough where people say, well, you just haven't found there's some, we'll get it. There's some mechanism under there somewhere that we'll get, like it's too complicated. So my suggestion is, and this is where we've gone. We've started looking at first sorting algorithms, which are extremely simple and transparent and deterministic. And now we have something even simpler than that. This thing is like one line of code. But with those kind of very minimal systems, I think it becomes really first of all, the shock value is bigger when you see them doing things that are not in the algorithm. You can see that right away, and like that's even more surprising, which I like. It sort of becomes immediately more obvious. Something, when somebody tells you it has a trillion dimensions, like, well, who knows what the hell it could do? Like the surprise value is almost right.
Yeah, I got you
You know what I
totally.
mean? So
I
so
one of the
so
reasons I use very small models.
so 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 something really small. So I have a suggestion, and see what you think of this. And
Yeah, yeah.
probably there are better suggestions, but this is just one that I'm aware of. How about remember the old Hofstadter and Mitchell copycat system, the
Mhm.
analogy making thing, right? It's a soup of concepts, and they're sort of floating around, and sometimes they sort of attach, and they make analogies that fit or don't fit. Something like that, I think that is extremely that doesn't have an enormous amount of data going in, that doesn't have tons of code, that doesn't have a trillion parameters, like some kind of very simple system, where we could quantify how much exactly extra are you getting, and how much what's the surprise value. Chris and I are writing this paper called Finding and Binding, and it's trying to sort of span the range from molecules finding their binding partner to concepts binding to things out in the world or to each other or whatever, and trying to sort of see and understand the symmetry of all that, but in really minimal systems. So something like maybe it's not copycat, maybe it's something else, but I feel like the measurability of it and the degree to which it becomes obvious to people that there's something more going on here than you would expect from a standard paradigm. We need something simple, right? And yeah,
Mhm.
I don't know. Maybe
Mhm.
maybe there's some version of language like yeah. But anyway,
It
that's
does and remember, I wasn't a linguist or a psycholinguist or a computational linguist. Language is just the one that smacked me in the
yeah,
face.
yeah.
It smacked all of us in the face, and if it hasn't, then you just didn't notice the blow, right? So I'm not specifically necessarily tied to language per se as the domain that this needs to, that of domain of research. It's just the one where I think so assuming you agree that it is ultimately an example, and you don't have to commit to that, but and I agree with you, massive models that are doing all kinds of stuff we don't understand. It is black box in the end, even though it's extremely simple, sort of fundamentally, it's kind of just annealing towards, it's just in parameter space, just fine, optimized for this function. There's all kinds of cool, crazy stuff happening in there. And I agree that people will probably, uh, many people will never be convinced that it's necessarily an example of this. Um, so I guess the question is, are there not maybe language, although language. we somehow ended up with this thing we call language that has these properties that is able to sort of self-assemble in this way. Could we? I don't want to think of it necessarily about like artificial languages or anything like that, but something like sequences or that have this kind of generative structure to them, but that are simpler.
Mhm.
And so maybe it is, and in some ways, some of the experiments I'm doing are kind of trying to do that. Like, what's the simplest uh, what's the simplest rule for generating sequences? Um, but those don't have this property, right? And that's sort of the point. Like if you use a simple rule like Fibonacci, you don't get extra.
So I don't know that okay. So just to say, I don't know that that's true because I don't want to kind of make too much of it until you see the paper and its and the data, but even what we've been finding is that even extremely simple deterministic generative rules have these kind of weird side quests that we didn't know about. And I
Mm.
mean, we found them in the sorting algorithms. This thing's even simpler. And like I think that these interesting, I mean, I've been calling them ingressions for lack of a better word. Um, I think they even affect very simple systems. I would
Mm.
not rule out. I mean, I don't know about Fibonacci. I haven't tried Fibonacci, right? So these are all empirical questions, so we have to try it and see. But the really simple thing that we tried, it has interesting properties that you would not expect. And so I don't know.
Cool.
So we can, so there's a couple of if it's not copycat, there's a couple of other things like Janet Wiles has done some amazing things. I don't know, she's an Australian. There's a talk by her on my channel, but also
I think
lots
I
of
saw. I think I
you
think I
must
saw.
have seen it. So
Yeah.
she's done this cool work on robots evolving languages to communicate with each other. And I think, and we're doing stuff now on using creating artificial interfaces for various types of systems to create composite entities. So like take two things and we provide almost like a corpus callosum, right? Like we provide the communication interface, and it's like xenobot and bacteria, plant and cellular automaton, like whatever, whatever, just and see if we can make a composite entity out of these things, right?
Yeah.
So the communication, I think that's a very rich once we get the tech off the ground, it's a very rich data set for looking for kinds of language. Like Andy Adamatsky was saying that there's some evidence of language in the signals from what was it, fungi or something, and of course people are debating it that.
Yeah.
So we can start looking for this stuff, right? I don't think it has to be incredibly
Yes, exactly.
complicated.
That so and that's sort of that's the I think the reasonable the language is probably not this crazy special case. It's probably
Yeah,
not.
right.
Is what led me to say that maybe more broadly cognition, but it's also there's probably manifestations of similar kinds of things happening all over the place. Maybe, even cellular, who the hell knows? And so capturing something like that, either a natural phenomena or perhaps, and I guess if there's a sort of a fork in the road here, a question for myself, for you, for potential collaboration is, do we go after natural phenomena? And I consider language an example of a natural phenomenon where we sort of discovered this kind of principle, um, and then and do we look at other phenomena, or do we try to construct kind of wired together kind of novel like maybe in a virtual system or something like that. And I have been thinking about, I'm still thinking about doing something like agents communication, things like that, exactly to see. Although my suspicion is they'll never come up with a language. I'm sort of on record saying that because I think, wow, language is too freaking good. Like if you give them a billion years, your non-organisms would never come up with this. But maybe I'm wrong about that. Maybe the
Yeah,
virtualization would, maybe nature came up with this stuff, but nature's really old and smart.
yeah.
Maybe you don't get it in a beaker in a contrived kind of environment, or maybe you do. I don't know.
I suspect it's easier than we think because not because the physical stuff we build is so smart, because the patterns they're under positive pressure. I think, right? That's my conjecture, is that when you make an interface, they come through. They're pushing out as much as you're trying to, like, if you're trying to implement something that has language, you only have to meet it halfway, or I don't know what the balance point is, but there's stuff that you, like I said, you get more out than you put in. So I think these kind of minimal constructed systems are probably good. What I'd love to know, and this I simply don't know the answer to this. What do people use as a criterion for language? In other words, here's a data set, whether it's SETI, I got a signal from, outer space, or whether it's like I'm recording, and I'm listening to espionage signal, like whatever. Like, how do you know that a set of exchanges back and forth has what's formally known as language? Are we looking for? Are we testing hypothesis for specific
Now you're
grammars?
hitting on it's a very serious. The field is not very serious. It's an engineering field, and the criteria are benchmarks, and that's a very very high level kind of that is a goal that you can't do at a minimal in
Mm-hmm.
a minimal system. It's like, can it actually, generate the right answers to these questions or right responses to these questions that are useful? I don't want to go on record saying it's not serious. It's serious engineering,
Yeah.
very serious engineering, but it's not serious science.
Mm-hmm.
It's not science at all. And people are not generally thinking about questions like criteria for being able to say when something's a proto-language. There's no such thing as sort of as a half language. You can get half as good on a benchmark. And what we with large language models, what happened was we were like, and then this, and so there was this qualitative shift, and so then it became now it's language, because it was doing it was almost useless on benchmarks, at least from a practical standpoint, and then it became an overnight phenomenon of real utility. But that's not what you and I are talking about exactly. That's really about sort of functional utility for doing the stuff that people do. We're saying what constitutes an example of this kind of structure imposing itself, doing work. What kind of work? So I don't think there is a clear set of criteria. The linguists were always doing their thing on human behavior, human language. The computational folks were trying to engineer. There really isn't a lot, at least in my reading of the literature, that tries to establish this kind of so we might have to invent that along the
Yeah.
way.
Yeah.
But
Well,
it's okay. So Shannon invented information theory,
yeah,
and,
yeah,
and
yeah.
it's
And
okay.
I'll tell you, and I apologize. I have about 2 minutes
Oh
before I
gosh, it's
hop
late.
over.
Sorry, I didn't realize.
No, no, it's okay. Um, yeah, one thing that I do think we should invent, and I don't know, I don't know if we need somebody else for this, or not, or what, but some kind of analog computing version of the Chomsky hierarchy, because this is something that people say, no, well, there's it's discrete, and there are different power levels to these formal systems, and but they're all kind of digital, basically, right? And I wonder if we could do some sort of analog computing version, and then does it end up also as a hierarchy of discrete power levels, or can we do this, right? Is there a physiological sort of analog version of these kinds of things that doesn't have to be, the digital model? So, or
Oh man, lots to think about. Okay,
right?
we run out of time just when we're like, let's get our hands dirty.
Yeah.
Sorry.
Well, so let's do this, right? Why
Yeah,
don't we go off and think about this for a little bit, specifically about some of these the potential models, and we'll have another meeting, and we'll talk specifically about, like,
awesome.
what to code up, actually.
Yeah, this was very for me. It clarified some stuff. It's for my own stuff, but also where we actually rubber meets road.